Hello viewers, how you guys doing? You're welcome to edumathhub. So in this video, we're taking the second aspect of where we stopped from last time. Okay, so this is operation on set. But before we move on, let's just have a quick recap of the basics of set. So in the last class, I told you guys that a set is any well-defined list or collection of objects, okay, similar objects that are combined together, okay, in a curly brace, okay, in a curly brace. And another thing you need to take note of is that sets can be finite and or infinite. Okay, a finite set is a set that has a limit. Take for example, you have a set of vowels, you have A, E, U. This is a finite set because it has a limit. When you write this set, there's a point you will get to where you have to stop. Okay, that's a finite set. But a set that does not have a limit or an ending is an infinite set. So if you do a set of natural counting numbers, for example, like when you write n is equals to, then you open your curly brace. When you write 1, 2, 3, 4, and so on, it goes on like that. Okay, it does not have any end or limits. Okay, this is an infinite set. Okay, this one is a finite set because that's the limit. You get to a point where you have to stop. Okay, so that's about finite and infinite sets. Okay, and I told you guys that sets are denoted by capital letters. Okay, while the members of the set are denoted by small letters. Okay, if you want to understand this better, you can look at it like this. So you have a set like this. You have A, E, I. So these three guys are members of set A. So A, which is the name of the set, will be written in capital letters, while the members will be small letters. That is if they are letters. Okay, then this A here is a member of set A. So you can write it like this. A is a member of set A because A is here. A is among the elements of set A. Okay, these members are actually called elements. But you can also write this symbol here stands for is a member of. Why this one means is not a member of. So if you look at this set here, you can see that Y is not among these elements here. Okay, Y is not among. So I can write something like this. Y is not an element of set A. It's true because Y is not here at all. So this one means it's an element of. This one means it's not an element of. There are many ways to define a set. Okay, a set can be defined by listing out the elements of the set, just like what you have here. A is equals to 1, 2, 3. Just list out the members of the set. Okay, there's also another way, which is using the set notation method. Something like this. Here you can see this guy here. A is equals to x such that 2 is less than x and x is less than 100. Okay, it means, so set A is equals to x dot, there's a colon here. This colon means such that, okay, such that 2 is less than x is less than 100. So if 2 is less than x, that means the first value of x is 3. 2 less than x means x is bigger than 2. So the first value will be 3. You go to 4, 5, and so on. But you cannot get to 100, so you have to stop at 99 because I told that x is less than 100. So the last number will be 99. So you can actually list out the members of set A like this, or they can give you in set notation form like this. So any of the two, is correct. Then you can see how set D was listed, the element of set D. So set D is equals to A, B, C, D, E. As you can see here, A, B, C, D, E. Okay, keep that in mind. Now let's move on to operations on set. Okay, operations on set. So for this next part of the video, we're going to be talking about intersection and union of sets, which is basically operation on set. So the first one we're talking about is this symbol, which stands for union. Okay, this is union, just like U. Then this one stands for intersection. So A union B, this symbol here, A union B, it means that union of A and B, it means put the elements of A and B together without repeating any element twice. Okay, why intersection means what they have in common. So for example, if you have set A and B like this, set A is 1, 2, 3, while set B is 3, 4, 5. So if you do the intersection and union, so you're going to have A union B. A union B just means put the elements together, just join them together, okay, without repeating any elements twice. So let me start with the element of set A. So I'm going to write 1, 2, 3. But B also has 3, so I'm going to skip this 3. I'm going to skip this guy because it has been written here already. So that will be 4, 5, 4, 5. Okay, These are the elements of A union B. Then A intersection B means what they have in common. Okay, check the two sets. Let's go. Check what is here, check what is also here. What is here should be here at the same time. So if you check that, you see that it's actually 3. 3 is here and 3 is here. So A intersection B will give you 3. So that's how to use intersection and union. It's very, very straightforward. So the next one is NA, which stands for the number of elements in a set, or the cardinality of a set. I'm going to skip this one because I've already talked about it in the previous video. That's just the number of elements in the set. Just count the number of elements that are in that set. Okay. If you need the video, check the link in the description. I'm going to be posting the link there to that first video. Then I've talked about this one. This one means it's an element of. Okay. This symbol means it's an element of. Why this one means it's not an element of. Okay, that means the particular element does not belong to that particular set. You understand? Okay. Now A prime, that's the next one. A prime means the complement of A. The complement of A. Now complement of A is written as A prime. Okay. Now let's talk about that one now. So finding A prime is actually very simple, or A complement. Okay. So this symbol here is the universal set, which is the set that contains all the elements needed for that particular question. Okay. All the elements in the sample space. Then A here is the given set A. So set A is 2, 4, 10. While the universal set is 2, 4, 6, 8, 10. So A complement means just remove this guy. This 2, 4, 10. Remove it from this universal set. Anything that remains, that will be the A complement or A prime. So I'll just come and remove 2, 4, 10 here. 2, 4, 10. Because that's what I have here. So what will be left is just 6, 8. 6 and 8. So I'll come here. 6, 8. That's how to do complements. It's very, very simple. Let's move to the next one. Now, empty sets or null sets, that's a set that does not have any elements. A set without any elements. Set of lecturers with 2 heads is not possible. Set of lecturers with 4 hands, nothing like that. So these are empty sets. Okay, empty sets. The next one is the universal set. I've talked about it. That's the set that contains all the elements needed for that particular question. Okay, all the other sets, they are pulled out from the universal set. Okay, that one is very straightforward too. Then let's go to subsets. So I've talked about this one in the previous video too. So check the description. You're going to see where I talked about subsets, and I posted the link for the first video. I talked about subsets, supersets, and other ones like that. Okay, then let me just skip those ones. We'll move to let me explain this symbol. So this symbol here means subset. This is a subset symbol. Okay, what this one means is not a subset. It's not a subset. Okay, then I'll move to the next one. The set with elements. This is a listing of the members of a set. Okay, so it means sets with elements, blah blah blah, x1, x2, and so on. Why this one here? When you see x like this with dot dot, it means such that set of x such that, then they'll put something in front of it like that. Okay, so I hope you get that particular part. So the null set, your null set, which is the empty set, is a set with no number, as in no element at all. That's a null set. It has no element. Okay, that's the null set. At times they might tell you to find, they might give you an empty set, t equals to, they'll put something like this. Then I'll say find the number of elements in this set. The answer is always 0, because there's not have any elements. The answer is 0. The number of elements in an empty set is 0. Okay, take note of that. Then for this next part, a null set is a subset of all sets. Yes, when you are doing your, this is what I'm explaining right now. When you are doing your subset, if you watch that previous video, check the description, you're going to see the link there, where I was talking about how to form the subset of a particular set. When you are doing subset, the first set you must write is the null set. Okay, then 2, you can write the whole set. Okay, so check that video. I don't want to waste time on that because I've talked about it already. Okay, so check that video in the description. You're going to see the link there. Okay, then this one's actually straightforward. So for this point here, which is 4 figure 3, we are told that A is a proper subset. That's this symbol means proper subset. Okay, if this is true, then we are told that NA is less than or equals to NB. This is actually true. This is because if A is taken out from B, let's assume your B is 2, 4, 1, 2, 4, 1, 3, 5. That's set B. And this is set A. So if I come here and just pick some elements, not necessarily all, like 2, 4, you see that if you find the number of elements in set A, you're going to get 2. So NA will be 2. When you do NB, number of elements in set B, you're going to get 1, 2, 3, 4, 5. You're going to get 5. Okay, you're going to get 5. You're going to get 5. NB is equals to 5. You can see that this 2 is actually less than 5. This is a proper subset because I did not take all the elements from set B. I only took 2 and 4. Okay, so this is actually true. The number of elements I'm going to pick out, since it's a proper subset means I'm not picking out all the elements from here. I'm just picking some of them. So if I count all the elements that I'm going to have, it's going to be less than this one. Okay, that's for the less than part. But if I form another set C, and I pick out all the elements from here, which is 2, 4, 1, 3, 5. By the time I do NC, which is number of elements in set C, I'm going to get 5. So it's the same as the parent element, which is set B. So they are the same. So it's either less than or equals to it. That's what I'm trying to explain to you here. Okay, it's very straightforward. Now for the next one, A, if A is a subset of B, then A is less than this. That's what I just explained just now. You can skip that one. Okay. Then if two sets are equal, that means they are subsets of each other. That's the meaning here. B is subset of A. Like B is a child of A. B can be taken out from set A. That's the meaning of this symbol here. B is subset of A. A is subset of B means A can be taken out from B. The same thing here. Look at set B and set C. Set B is 2, 4, 1, 3, 5. Set C is also 2, 4, 1, 3, 5. So two of them are equal. That means they are subset of each other. They can be taken out from each other. Okay? So both of them are equal. Sets B and set C are equal. That's what you have here. Alright, so let's move to the next part, which is the main part of the video, which is going to be Venn diagrams. Okay, so listen up. This part is kind of complex, but if you listen very well, I'm sure you're going to get it. So let's go. So let's talk about Venn diagrams. So we're starting with set A. Okay, so a Venn diagram, you need a rectangle. After your rectangle, you indicate your universal set somewhere on the rectangle. Then this is set A. So if you want to indicate set A, all you have to do is draw a circle, then you shade the circle like this. That is set A. You're talking about the elements that are inside set A. So you just have to shade this circle. Okay. Then if you want to do for A complement, A prime, you're talking about the elements that are in the universal sets, but they are not in A. So that means you're going to shade outside here. So it will look like this. So you're going to have your universal set. You have a circle. This is set A. This will be your universal set. But what you're going to shade right now is the outside like this. The outside. Your shading should not actually enter into A. So this is universal set. This is A complement. Why this one is set A. So that's to tell you that once you have your diagram like this, if this is your set A, this is your universal set. Outside it like this is A complement. While inside is A. Okay, this thing is very, very important. Once you get this thing, you will not have problem by the time you start doing two sets that are together like this. So that means you have two different parts here, which are set A, the main set A, which is everything inside the circle. Then you have everything outside the circle, which is A prime or A complement. So take note of that. There are two parts, A and A prime. Everything outside A is A prime or A complement. Okay, so for A prime, you're not going to shade the circle of A. Nothing concerns you with what is inside A. You are dealing with the outside of A. Okay, now let me join two sets together now so you can get the basic idea. So if I join two sets together now, if I want to do A and then B, A intersection B and A union B. So let me put them together now. So it will look like this. This will be set A, set B. So listen up. So once it's like this, you can easily get the answer. This part here, intersection B, means what they have in common, which is this part here, what A and B have in common, where they are touching each other, where they meet each other. That's what they have in common. Okay, that's A intersection B. So this diagram is for A intersection B, what they have in common. Okay, then for A union B, it means all the elements in set A and set B all together. So that one will look like this. Very simple. It will look like this. So you have your set A, you have your set B. So A union B, it means everything in A and everything in B. You have to shade everything like this. Your shading must not go out of A and B. So you are considering everything inside A and B. This is A union B. Okay, now if this is A union B, you cannot apply a scope. It is A union B. Everything outside like this, everything outside, if you're talking about this outside part, that means you are going outside of A union B. And anytime you are going outside, you must put prime. Okay, you must put prime. So if it's A union B, you can actually get this outside part as A union B prime, because you are going outside of A union B. This is A union B here. This is like a building. I'm going outside the building. Okay, I'm going outside. So once you're going outside like that, you have to prime it. A union B prime. Okay, now let me put all these things together so you can actually appreciate it better. Now if I put the three concepts together, it's going to look like this. So you have this, that's B, A, universal set. Now this part here is A intersection B. That's where A and B meet. Okay, you've gotten that one. This particular part here, this is B only, B alone. You can see the circle of B. Let me change the color so you can see it better. You can see the circle of B. This is the circle of B that's going like this, circle of B. Okay. Now I don't want A to be involved. That means I have to move like this. I don't want to involve circle of A. This is the circle of A here, going like this. Okay, but I don't want the circle of A to enter into B. So I need to move like this. I want to go from B, but I don't want to enter A. So I need to move like this. This part means B only. The elements in B only. Okay, that's the meaning of this part. This part also means A only. That's A only. That's the meaning of this part. So this part here, since I'm not involving A at all, that means I'm outside A. That means I have to prime my A. So this part here means B intersection A prime or A complement. I'm involving B, but I'm going outside A. A must not be involved. The same analogy, this part means A intersection B prime. Okay, set can also be subtracted. Okay, this part, or this B intersection A prime, at times in some textbooks they write it like this. They write it as B minus A. The same thing. It means you are talking about the elements that are in set B but are not in A. So your focus is on set B. So you just subtract A. You remove the circle of A. The circle of A should not be involved at all. So just know this particular part. Intersection B. Then the outside here, just know that the outside here is always A union B prime. That's what the outside is. Once you have two sets, the outside is always A union B prime. A union B prime. So these are these parts. If you can know these parts, forget. You answer any question. So this part is A intersection B prime because I'm not involving B. I'm cutting B out. I'm cutting A out. So here will be B intersection A prime. Then A intersection B is where they meet. So anytime something is not involved, just prime it. Okay, prime it or complement it. So that part will not be involved. So this is A union B. This one is for two sets that have something in common. So you can see that they have something in common. They are meeting. So they are joint sets. You call them joint sets because they have something in common. Something is common among them, so they must meet. But what about disjoint sets? These are sets that you don't have anything in common. So that one will look like this. So for disjoint sets, they will not meet at all. This will be A and this will be B. They will not touch each other at all. Okay, they will not touch each other. They will not meet at all. This is for disjoint sets. But you can get some basic facts from here. So don't forget that outside B, this is set B here. Outside B means everything here like this, including A. Everything like this is outside B. Okay. So once you go outside B, you're going to see A. because this part here, this is set B here. So outside B, that's where A is. Outside like this, everything is, this is B complement like this. This is B complement. And if you shade it, they are going to involve A. A is at that particular point where B complement is. So the same concept applies to A too. This is set A here, as you can see. So everything outside A, that means you are going outside A. Everything here like this will be A complement, including where B is. Everything like this will be A complement. Okay. Now you can actually get some small relations from here. You can see that A and B are not joined together. They have no intersection. So you can say B intersection A is equals to empty set. Nothing is common. They don't have anything in common. They are disjoint. Okay. Then you can also say B is a subset of A prime. I will explain to you. That means B is the baby, is the child of A prime. You can actually pick that out, as you can see from here. This is A here. This is set A here. Right? This is set A. A prime means I'm going outside of A. So that means I will see everything from here like this. I will see everything here, everything from here, including where B is, including set B like this. Everything like this is A prime. Sorry about the shading. Okay, this is A prime. But this A prime, where it is positioned, that is where set B is. That is where set B is. So that means B is part of A prime. That's the meaning of this statement. B is like a child. B is inside A prime. That's the meaning of this statement here. Okay, I hope you understand that particular part. The same thing also applies if you reverse it for the other one. So if you reverse it, it will look like this. So if you reverse it, you can say A is a subset of B prime. The same concept. Okay, the same concept. Okay, then another thing that you can also pick out from here is you can say something like B prime intersection A, the same thing as A. Okay, don't worry yourself, it's very simple. Let's look at B prime first. Where is B prime? B prime means everything outside B, Abi. What are the things that are outside B? This is B here. I'm going outside B, so I'm going to prime it. Everything like this. So I'm priming everything like this. Everything, including where A is. Including where A is, I'm priming everything like this. So that's B prime, Abi. That's B prime. What is set A? This is set A here. Let me use this kind of shading to shade it. This is set A. So if someone should ask you, what does this shading that I shaded here, this B prime, and this particular part, what do they have in common? You see that the two shadings are meeting at this particular point. And this particular point where they meet is actually set A. So this expression is true, or this equation is true. Okay, I hope you understand. So with that same analogy, you can also say A prime intersection B is equals to B, and you get the same answer. Both of them are the same concept. Now let's move to something else. So as a quick recap, remember that when you have two sets, just master this particular thing and you won't have any problem with any question. Once you master this, you won't have problem with any question. So as a recap, once you have two sets like this and the two sets are meeting, this is A and this is B. Where they meet is A intersection B. If you need this part alone, you will do B. Since you are not involving A, that will be intersection A prime. If you need this part, since you are not involving B, since B, the circle of B is not reaching this particular part, you're just going to write A intersection B prime. Then this outside here, this outside, all this outside here, all this outside is always A union B, then prime it like that. Once you know this one, forget, you don't have any problem with any question. Now let's go to the next aspect, which is how to use De Morgan's theorem. So I'm going to give you guys a theorem, De Morgan's theorem, which will help you to convert, like when you have a union like this, a union expression in brackets with a complement outside, how to convert it to intersection. So it's very simple. Just allow the complements to go into the bracket as if you're actually expanding. So this complement here, once it comes inside to A, you have A prime, then you will reverse this sign to intersection, then you're going to have B prime. So these two are equivalent, they are the same thing. Okay, you can also have it in another way. You can give something like this, A prime intersection B, and you'll be told to prime it. If you prime this guy, you're going to have A will be normal because you are priming it, so that will be A prime prime. This sign will be changed to union. Then you're going to have B prime. Then you're going to introduce a prime outside. A prime prime is the same thing as A. So you're going to have A union B prime. Then with a prime outside. So let's try to master it. Let me do one more so you can get it better. You have A intersection B prime. And you're told to prime it. They will not be primed there at first. They might be prime and they might not be prime. But this one, there's no prime at all. So you're told to prime it. So you're going to have A prime first. This sign will change to union. You're going to have B prime prime. Cover your bracket and put a prime outside because you're told to prime it. That means a prime must be in your answer. Okay. So that means you're going to have A prime union B prime prime is B. Then, so in this case, in this particular case, if you are given like this, you'll be told to remove the prime. So you'll be told to remove the prime. While in this case, you'll be told to prime it. So in this case, if you want to remove the prime, this prime will come into this bracket here. So you're going to have A prime prime. This one will change to intersection. Then you have B prime. A prime prime is the same thing as A. Then intersection B prime, which is the same answer as what you have here. So once you understand these parts, trust me, you don't have any problem again. Now let's go to how to identify the parts of a Venn diagram. There will be some questions that will shift some parts of a Venn diagram, and you'll be told to write out using set notation what that particular shading means. So let's move to the next aspect. In this exercise, you are told to identify the shaded portions in the figures below. Okay, you have to identify the shaded portions. Before you can approach this kind of question, you need to first of all remember this thing here. Remember the parts of a Venn diagram when you have just two elements. Once you can identify what each part of this Venn diagram is, then you won't have any problem in identifying any other question that you're given. So where the circle of A and the circle of B, where they intersect, where they meet, is always A intersection B. Now this particular point, since you are not involving A, the circle of B is not reaching this particular point. The circle of B is not reaching here. So this point will be A intersection. Then you have to prime your B because you are cutting your B out. So you are outside circle of B. This point is outside circle of A. This circle of A. So this point is outside it. So you're going to call this part B intersection A prime. Then this outside here, everything on this outside here is always A union B complement. Okay, that's how it is. And don't forget that A union B complement, because of the prime outside, using that De Morgan's triangle, once it enters, it will be A prime. This one will change like this. This one will be B prime. Both of them are the same thing. So let's go back to the question now. Just keep all these things in mind because you'll be needing them for the question. So let's come here. So the first one here, we are told to identify what this part represents. So we forgot to look at what is shaded. The part that is shaded is only A is shaded, but the shading is not affecting this part, and B is not involved. Okay, B is not involved. So just compare it with what you have in your basic parts here. So this is the part that was shaded. This is the part that was shaded. And what is this part called? So you can see it from here. This part is A intersection B prime. So the answer to this question, this first one, the answer is A intersection B prime. Shikina. Okay, for number two, they shaded only the middle where the two circles meet. Only the middle. So compare it to what you have. The middle here is always A intersection B. So that means they shaded A intersection B. So the answer to this question is A intersection B. Okay, so I hope you understand that part. Then for this next one, nothing is shaded. They didn't shade any part. It's kind of confusing. They didn't shade any part. They didn't shade anywhere at all. So once nothing is shaded, that's an empty set. That's the answer. That's how you represent an empty set. Okay, empty set. That's how you represent it. So nothing is shaded. Then for the next one, okay, I think we've done this one before. Let's go to the next one. Now for this next one, you can see that what was shaded is outside A and B. That's what they shaded. outside of A and B. The shading is not affecting inside of A or inside of B. So compare it with what you have. If you compare it, you see that they shaded the outside. And what is the outside? The outside is always A union B prime or A union B complement. That's what was shaded. So that means the answer to that question is, so this is A union B, cover it like this, complement. I haven't do it another way. This circle here, this circle, everything like this. If you shade only this part like this, only this part, okay, only this part, that is A union B. Okay, but since you are cutting it out, you're not involving it at all, then it has to be prime. It has to be prime. So it's still the same thing. And you can also write this one in another way. If you want to, if you prime this, that will be A prime intersection, then prime will come in B prime. You can also see it like this in your option in case you don't see this one there. So both of them are the same thing. So let's move to the next one. Now for this other one, this one is very straightforward. You can see that the shaded part is only set A. Only set A was shaded. They shaded only set A. So the answer is just A. So let's move to the next one. For this next one, we have this diagram here and we have to write it in set notation. So if you look at it very well, you see that the whole of A was not shaded at all. Okay, the whole of it was not shaded, but every other thing was shaded. Every other thing outside the house of A was shaded. So that is obviously A complement. This is A complement. So the answer to this one is just A complement or A prime. Okay. Now let's take the next one. For this next one, we have something like this. So let's check the part that is not shaded at all. Okay, the part that is not shaded. You can actually do it in two ways. You can use the part that is not shaded and the part that is shaded. So let me use the part that is shaded first to get the answer. So this part is shaded. Everything outside here is shaded. Okay, everything outside there is shaded. Now what is this part called? Go to your diagram and check it out. You see from here, that part is outside here. That is A union B prime. As you can see from here, outside is A union B prime. Okay, so since that outside was shaded, so you're going to have A union B prime. I'm using the shaded part. That will be A union B prime. Okay, that's the outside part. Now this other part was shaded. This inside part, we already know here is A intersection B. Normally A intersection B. So I'm going to use union now. Union A intersection B. So that's the answer to this one. But I can also write it another way. If you prime this guy, if you allow this prime here to enter here, to look like this, in case you don't see this one in the option, that will be A prime. This one will change to intersection. Then this one will be B prime. Cover your brackets. Okay, then you have your union with A intersection B. So that's the answer to that. Okay. Alright, there's another way to do it. I'm going to teach you another way of solving this question in case you don't see this particular answer in your option. Okay. Now, for this answer, I consider the shaded portions, right? And I use union. But for this next way, I'm going to consider the cut out parts, the white parts, not the shaded parts. And I'm going to use intersection to join them together. So I just need to know what is this part representing and what is this part representing. So from what I did then for two sets, you can see that this part, let's just check it here, you see it now. So this part here is A intersection B prime, B intersection A prime. So let's come back here and you see they are the same thing. They are the parts that are not shaded. So just blend it here with intersection. So this part here, this one here is A intersection B prime. Okay, but since it has been cut out, you can see that it was not shaded. It has been cut out. So that means you have to prime it. You prime it. Intersection. Then this other part, this part was not shaded too. It's just white. It was not shaded. That will be B intersection A prime. But you have to prime it. You can leave your answer like this. But if you want to go further, let the prime outside. Let it enter into the bracket. This prime, let's go into the bracket. So that will give you A prime union B. Okay, this one will be intersection this prime will come into the bracket there. If you change some things, that'll give you B prime. This one will turn to union A. So you can just leave it like this in case you don't see this one in the option. This one too is also correct. Okay, I hope you understand. Now let's go to the next one. So for the next one, we have this. Let's just check the part that is not shaded, okay, to get the answer real quick. So this part normally, we know this part normally is always A intersection B complement. But since it has been cut out, you can see that it's not shaded. That means they have cut it out. So that means you have to prime it. You need to prime it. By the time you finish this up, if this prime comes into this bracket, it will be A prime. This will change to union. Then this will be B prime prime, which is the same thing as A prime union B. B prime prime, same thing as B. Okay, so that's just that. Then actually you can also do it another way. Everything at this shaded portion here, like this, is already A prime, right? Everything outside A, including everything like this, is already A prime. So that means you have A prime. So the whole circle of B was shaded. Okay, so that's A prime union B. A prime union B. This is the same thing as what we got here. So any method you like, you can just apply it. So for this next one, just let us check the part that is not shaded. Okay, this part is not shaded, and you know that this part is always A intersection B, right? So A intersection B. So since it was not shaded, you have to prime it. So you can leave it like this, or let the prime enter. That will give you A prime union B prime. Okay, so that's for that. Then for this one, you can see that everything was shaded. Everything in the circle of A and everything in the circle of B. This part was not shaded at all. This part was not shaded. So you can easily get the answer. That is, you can get it in two ways. Normally this part that was shaded is A union B. This is the answer here. The shaded part is A union B. Circle of A, circle of B was shaded. That means what they have in common. But if you don't want to use this method, you can also consider the part that was not shaded. This part was not shaded. It was not shaded. Then what is that part that is not shaded? You always know that that outside part from our diagram here, that outside part is always A union B prime. So if you go back and just replace it there, this outside part here is A union B prime. So just write A union B prime. But since it has been cut out, you can see it was not shaded. That means they cut it out. Then you have to prime this answer. You have to prime this answer, A union B prime. You need to prime the answer. So by the time you prime the answer, prime will cancel prime. You just have A union B. That's the final answer, which is the same thing as this one. So I hope you understand. Then for this next one, you can see that everything was shaded. Everything was shaded. They shaded everything. So that is universal set. That's how to represent this one, universal set. If nothing was shaded, that is empty set. If not, if they don't shade anything there, that would be empty set. That's the answer. But if everything was shaded like this, then the answer will be universal set. The next thing for you to know concerning your Venn diagram is when you have intersection of three sets. And when you have three sets, they give you a question involving three sets. You need to know what each part represents. Okay, so it's very, very simple and very straightforward. All you have to do is just check the circles. Just try to trace the circles and see where they meet. So for example, this central point here, where the three circles intersect, this central point is A intersection B intersection C. That's where the three of them meet. Okay, so that's what this part represents. Okay, now you can also get other parts easily. This part here, for example, this part here, you can easily pick it out. You can see that this part, the circle of A is not reaching there. So let me change the color to black. circle of A, this circle of A going like this, is not entering this particular point. Circle of A is not reaching here. So that means at this point here, A is not involved at all. So that means you must have A prime. But B and C are involved since their circles are meeting. So this part here is B intersection C intersection A prime. The same thing with this one here. At this point here, B is not reaching here. This is circle of B. Circle of B is not reaching this particular point. So you can easily get this part here. This part here, for example, will be A intersection C intersection B prime, because B is not reaching there. So with that same idea, in a similar way, this point can also be obtained too. All you have to do is check if something is reaching there. So this point C is not reaching here. So this particular point here is just A and B that are combined. So C is not reaching there. So that will be B intersection A intersection C prime. But how will you get this part here? This part. At this part, the circle of A and B are not reaching this point at all. Circle of A and B are not reaching there. So that means you have to have A intersection B complement C complement. B and C are cut out. They're not reaching there at all. This point, for example, this point, circle of A is not reaching there, circle of B is not reaching there. So both of them must be primed. So you're going to get C, ordinary C, intersection B complement, intersection A complement, and so on like that. Okay, you can see the full diagram here in case you need it. This is the full diagram here. That will give you a better view of how these points are related. Okay, then I'm going to give you a formula that will help you when you are doing set theory, when they give you a question involving Venn diagram, maybe 2 sets or 3 sets. So let's quickly talk about that formula before we take questions. So the formula is just NA union B is equals to NA plus NB minus NA intersection B. It's very important formula when you're dealing with those two things. If you're dealing with 3 things, then you have to use this formula. Though you don't need to cram it, just note that it is negative when you have something in common, that's the intersection part. And this left hand part is always A union B. Okay, then if there are actually 3 sets, then this is the formula here. It's the opposite of this one. It's going to be plus where you have intersection for the 3 sets. Okay, then it's going to be NA, NB, NC. Then it's going to be negative for where you have intersection of just 2 sets, 8 minus N intersection B minus B intersection C minus here. But when you have the 3 of them meeting together, it's going to be plus. That's the only difference between the 2. Okay, note this formula down. It's very important. We're going to be applying it. Okay, when we start solving questions. So that brings us to the end of this set theory. So we're going to take questions right now. We're going to take questions, some important questions. So let's go. So right now we're going to be taking some past questions. Okay, some very important past questions. So let's get right into it real quick. So we're told in this question that in an examination, 18 candidates pass mathematics, 17 candidates pass physics. Okay, so for mathematics you can use M. So that means we have NM, number of elements in M. M is mathematics, so we're going to put 18 here because you have 18 right here. For physics, 17 candidates pass physics, so we're going to put NP. We're going to put 17 there. 11 candidates pass both of them. 11 candidates pass both subjects. So since you have both there, you're going to write M intersection P. That's what they have in common. So the number of candidates there is 11. Okay, and one candidate failed. Okay, one candidate failed. That means this candidate is not involved at all. The candidate failed. Then you are told to find the number of candidates that passed mathematics only. Okay, so you can put it in Venn diagram. Don't forget one candidate failed. So you put it in Venn diagram to look like this. So you have M, and this is P. So it should look like this. So let's get the middle first. The middle is NM intersection P. That means people in the middle here is 11. And we are told that NM, everything in circle of M like this, everything in this circle here is 18. You can see it from here. So that means this place here will be 18 minus 11. That's 7. Then everything in P, circle of P, everything here is 17. That means this remaining part here will be 17 minus 11, which will give you 6. Then one person failed. That person will be outside of the Venn diagram like this. Okay, so this is the question placed in Venn diagram form. So you can use this diagram to answer the questions. So let's check. So we are told that the number of candidates that pass mathematics only. So what we are looking for is just this part here, just this part. People that pass mathematics only. So the answer is 7. So just write 7 here. So just write 7. Next one, number of candidates that pass physics only. So physics only is just this part here, which is 6. So just write 6 here. It will just be 6. And for the last one, total number of candidates that sat for the exam. So you need to add everybody that sat for the exam, including the person that failed. So only one person failed, the person that failed here. So you need to add everything inside here. So if you add everything, you get 7 plus 11, 7 plus 11 plus 6 plus 1. This is 7. 7 plus 7 is 14. 14 plus 11, that will give you 25. So 25 people sat for the examination. So this answer is 25. So that's the answer to that question. Let's take the next one. For this next question, we're told that in a party of 30 young children, that means universal set is 30. 12 were served Coca-Cola drink. So let's see, Coca-Cola represents C. So this one will be 12. Then 14 were served Pepsi. So P is Pepsi. So it will be 14. If 9 children had Coca-Cola but not Pepsi. So 9 had Coca-Cola but not Pepsi. But not Pepsi. That means Pepsi is being cut out. Okay, Pepsi is being cut out. So you're going to do it like this. C intersection P prime. That means but not Pepsi means you're cutting Pepsi out. So just put N here. So this will give you 9. On the question you can see is 9. Then define the number of children that were served both drinks. So you can put this in Venn diagram real quick. So you have this circle here, this circle here. This one is C, this one is P. That's for Pepsi. So everybody is 30. Everybody in this rectangle here, everything here is 30. Okay, so C intersection P prime is here. From what you did from 2 sets, this place will be 9 because P is not involved at all. That's 9. Then NC, everything here is 12. Okay, if everything here is 12 and this place is 9, that means this place is 3. You understand? Then NP is 14. Everything here like this is 14. But 3 has gone out. That means this is 14 minus 3. That will be 11. Okay, so this is the representation of the stuff. Then this is universal set, which is 30. So you can use this diagram to get the answers to those questions. So let's do it now. So the first one, find the number of children that were served both drinks. There are people that are in the center. So number of children that served both drinks, the answer is 3. So let's write 3 here. The answer of this one is 3. Number of children that were served both drinks, the answer is 3. Number of children served at least one type of drink. We're talking about union right now. Serve at least one type of drink. So you need everything in this circle like this, everything here like this, addition of everything here. So let's add everything there. So you have 9 plus 3 plus 11. Okay, so 9 plus 3 is 12. 12 plus 11 will give you 23. So that means 23 children were served particular kind of drink. So this one is 23. That's the answer. And the number of children not served any of the drinks, that is compliments. Number of children that were not involved at all. So if 23 children were involved, and all the children there were 30, number of children not involved will be 30 minus 23. So that will just give you 7. That means 7 children were not involved. They were not served any of the drinks. So the answer to this one is 7. Okay, so the answer to the question. So we take the next one. A game master of a school called 50 students of the school to select 2 teams in football and volleyball. So football, we're going to use F for that one, and volleyball, we're going to use V. 30 students could play football. You can see it from here. So just write NF. So that's 30. Okay. For the next one, 20 students could play volleyball. So that will be NV. We're going to put in 20 here. If 8 students could play both games, now 8 students could play both games. That's intersection. Both means intersection of F and V. So you're going to write NF intersection V. Where they meet, they have 8 there. So before you answer this question, just try to represent all these guys in the Venn diagram. So let's just quickly do that. So you have this circle, you have one down like this. So this is F and this is V. Okay, put your rectangle. So where they meet, that's F direction V, is supposed to be 8. Okay, this is NV. NV, everything is 20. So this whole circle of V is 20. So, but 8 has gone out. So this supposed to be 20 minus 8, that will be 12. Then the whole circle of F is 30, as you can see from here, NF. So this supposed to be 30 minus 8, that will be 22. So this is what you have. This is what you're going to use to answer the question. So let's go to the questions now. Number of students that could play football but not volleyball. So volleyball is not involved. So that means you are priming volleyball. So volleyball, this circle should not be involved. So that means our answer is just 22. So the answer to this first question here is 22. That's the answer. Number of students that could play volleyball but not football. That means F, circle of F should not be involved. This circle should not be involved. So this is our answer here, 12. So that means this place here is 12. Number of students that could not play any of the 2 games. So we need to find people that are actually outside. People that are outside here. Before you can do that, you need to add everybody that are inside the circle. Add everybody here first. So let's add everybody. If you have everybody, 22 plus 8, that will give you 30. Okay, 30 plus 12. 30 plus 12, that will give you 42. So that means 42 people are actually involved in this game. But since 42 people are involved, how many people are involved in the whole, as in all the students in the school? There are 50 people. But 42 students are actually playing the sports of football and volleyball. That means people that are not involved are 50, all the people involved in the whole class, minus people that are actually playing the game, 42. The minus that, you're going to get 8. That means 8 students are not involved at all in any of the games. Okay, so that's the answer to that question. I hope you understand how I got the answers. So for this next question, we are told that at a certain conference of 100 people, there are 29 Indian women and 23 Indian men. So all the people that are involved, universal set is 100. Okay, 100. Then the number of women is 29. These are the Indian women. Then the Indian men, they are 23. The total here will give you 52. That means there are 52 Indian people there. Okay, now that's the basic of what we know for now. Out of these Indian people, 4 are doctors. So out of these 52 people, out of the 52 of them, 4 of them are doctors. Okay, and 24 are either men or doctors. So let's just say doctors be D. So doctors, D is doctors. So the number of people that are in the doctor sets is ND. That's 4. But they gave us something here. I told that 24 are either men or doctors. Or in set stands for union. Okay. So we have men M and D, doctors, combined together. So you just have 2 sets there. So you can apply your set theory theorem. So you can see that N doctor union men is 24. Okay, so from here you can find the people that are in both sets. So use this formula for 2 sets. Just combine both of them, doctor and men. So you have ND union M. You're going to get ND intersection M. So you need to minus intersection from the formula I gave you then. So what they have in common is this particular part here, but the all parts will be 24, as you can see it from here. ND union M, because you are told in the question that 24 are either men or doctors. Okay, so here will be 24 equals to all the doctors ND, they are 4, plus NM, all the men, check it here, you see it, all the men are 23. So come here, put it here, 23 minus, let's just call this guy X, as in you want to know the number of men that are also doctors at the same time. So if you finish this will give you 24, this will give you 27 minus X. From here you can find X. X is 27 minus 24. That means X is 3. That means there are 3 men who are also doctors at the same time. So there are 3 men who are also doctors. But from this question, you will see that you are told that no foreigner is a doctor. That means all the doctors are actually Indians. And since 3 men are doctors, you are told to find the women doctors that are there. The women doctors. Okay, and the women doctors will definitely be 1. It will be 1. Since all the doctors are Indians. Okay, and they are just 4 in number. Out of these 4 in number, 3 of them are men. That means the last one will be a woman. Okay, 4 minus 3 will give you 1. So the answer is 1 female doctor who is an Indian. So the answer is 1. So I hope you understand it. We are told that a survey was carried out on 40 travelers. That means universal set is 40. 12 of the travelers said they had traveled to Ghana, but not to Cameroon. So this but not to, that means Cameroon is being primed, okay, it's being complemented. So G is Ghana, Cameroon is C. So 12 of them have gone to Ghana, so that will be N, G intersection C prime. That will give you 12. 8 of the travelers claim they have traveled to Cameroon, but not to Ghana. So 8 of them have gone to Cameroon, but not to Ghana. So that means we are priming Ghana now. So that will give us N, C intersection G prime. So the answer here is, we are told is 8. 10 of the travelers said they had not traveled to any of the 2 countries before. That means 10 people are not involved at all. 10 people are not involved at all. Which means that what will be outside of your Venn diagram, which is always G union C prime, that part is just going to be 10. Okay, that will be outside the diagram. We'll draw a Venn diagram. So let's draw the Venn diagram first, then we'll come back to the question. So let's just go just like this. So draw a rectangle first. So you have this part, you have this part. This will be G. This will be, that's Ghana, this is Cameroon. So from this question, we are told that, so N G intersection C is equals to 12, which is this part here. C should not be involved. Here is 12. And C N intersection G prime. So G should not be involved. This is it here. This piece is 8. Okay. and we are told that 10 people are not involved. 10 people are not involved, so that will be outside here. That means people that are involved, they are 30. That means everything in this circle like this must give me 30. If you add everything, so let me just call here x. So if you add everything in this circle must give you 30, because there are actually 40 people and 10 people are not involved. So you must get 12 plus x plus 8 must give me 30. This is 20. 20 plus x equals 30. From there you get x equals 30 minus 20. So x is 10. That means people that have traveled to both countries are actually 10. So this place is 10. So let's go to the questions now. Number of travelers that have traveled to both countries before. So this answer is 10. That's the answer to this one. Number of travelers that have traveled to Ghana before. To find the number of people that have traveled to Ghana before, all you have to do is look at the whole circle of G. So this is the whole circle of G here. Look at everything like this. So what are you going to see there? You're going to see 12 and 10. So you add it together, 12 plus 10, that will give you 22. So that means now people that have traveled to Ghana before is 22. Yeah, let's take the next one. So we took that universal set equals to splendor. Okay, they give us splendor. Next one, H is spend, then K is poor. Then we have to find the elements of all these guys here. Then I have to compare some things here, to compare some answers and see what we noticed. So let's take them one one. So the first one, I have to find H union K. So let's do that real quick. H union K. Maybe. So let's put all these elements together. That's H union K. Put all these guys together. If any element is repeating, write it once. So that means you have X. So you have S, P. P is twice. So write it once. So you have E and D. Then OUR. So that's H union K. That's the first one. Okay, second one, I have to find H intersection K. H intersection K. That means what does H and K have in common? So we have P here, you also have P here. So what they have in common is just P. So this one will just be P. That's the answer. You have to find H prime union K prime. H prime union K prime. Before you can do this, you need to find H prime first. Then you do K prime. Then you union the whole answer. Put the answer, combine the answer in like union. So let's find H prime. So what will remain? That will be LOUR. So I need LOUR. That's what will remain. So let's come here. LOUR. Then K prime. Remove POUR from here. So what will remain? SLEND. SLEND. That's what will remain. Okay. Write it out here. SLEND. Then put them together. Union means put them together. These two guys, I'm going to put them together now without repeating any element twice. If you check, you see that L is repeating, so now means you need to write it once. So you have L, S, and just say OUR, then END. That's H union K prime. H prime union K prime. The next one, we have to find H prime intersection K prime. Okay, H prime intersection K prime. See it here. H prime intersection K prime. You've already done K prime and H prime. So just check what they have in common. You check very well. You see the common element there is L. So they have L in common. So the answer to this question is L. Then for the next one, you have to do H union K. H union K prime. H union K prime. So let's find H union K first. I think we've done that before. H union K prime. So let's go to H union K. This H union K here. So I'm going to remove it from here. So I'm going to remove SPENDOUR. SPENDOUR. So it will remain only L. Only L will be left. So this guy is equals to L. That's H union K prime. And the last one, H intersection K prime. H intersection K, you have to prime it. Now look for your H intersection K. I think we've done it before. H intersection K. I think that gave us P. So but we have to prime it now. So come and remove P from here. Remove only P. All you have to, you get slender. This is what will be left, slender. So that will give you slender. So you have SLENDOUR. Separate them with commas. So that's the answer to the question. Then we are told to compare some things there. Compare H union K prime, H union K all prime, and H prime direction K prime. So H union K prime, this is here. You have to compare it with H prime direction K prime. Then so what do you notice? Notice that both of them have the same answer. Okay, that's what you notice. Both of them have the same answer. The next one, you are told to compare H intersection K. This symbol is intersection. Okay, and H prime union K prime. So H intersection K prime is it here. H intersection K prime, that's slender. You have to compare it with H prime union K prime, which is the same thing as slender. This is also slender. If you start it with S, you also get slender. So that means both of them have the same answer. So they have the same answer. These two guys have the same answer. These two guys have the same answer. And basically, it's from that demogram theorem I taught you then that if you have A union B, if you are priming it like this, once this prime enters here, you're going to change the union to intersection. This one will be A prime. This one will turn to intersection. This one will turn to B prime. And if you have A intersection B prime like this, once the prime goes into it, it's going to turn this one to A prime. This one will change to union. To change to union, this one will now be B prime. Okay, so I hope you understand that part. Let's take the last set of questions. So that the diagram shows the universal set and the three sets A, B, and C. You have to copy this diagram and shade this region. You have to shade this particular region. Okay, you have to shade it in this diagram here. So let's just copy it. So you have A, you have C, you have A, then you have B. B is inside A. So you have to shade this region. Very simple. All you have to do is you need A union C first of all. You see that there's a prime on top of the B. What you're actually doing is A union C intersection B prime. there's a prime on this B. So that means in your answer, B will not be shaded at all, because there's a prime on it. Okay, now since there's a prime on this B, B will not be shaded. So all you have to do is just shade A union C. Just shade A union C. So your shading should just cover A and go to C, something like this. You shade everything like this, but don't let your shading enter into B. It must not enter into B, because B has been cut out. B is primed. So this is what your answer will be like. Sorry about the shading, but this is just the basic idea. Okay. For the next one, for each of the diagram below, express in set notation. Express in set notation. So this one is the reverse of the first one. The set represented by the shaded area. Okay, so let's do this. If you check this one out, you see that C was not shaded at all. So that means C has been primed. That means there must be a C prime in your answer. You must have a C prime in your answer, because C was not shaded at all. And also B was not shaded at all. So there must be a B prime, C prime. And they didn't shade B. And they didn't shade C. Now to get the answer, you see that it's only A that was shaded. So the answer will look like this. Because A was shaded, they're going to have A intersection B prime, B prime. B was not shaded at all, so B prime. Then C prime, intersection with C prime. So that's the answer to that question. Then for this next one, just check the shaded regions. Shaded regions. Okay. Now I'm using the shaded regions now. This shaded region here, you know, this is A, the middle of A and C. This is where they meet. So that place is A intersection C. That's this place. And this place here is B. So just union the two of them. Just union the two. Since you're using the shaded part, just union the two of them. That will be A intersection C in brackets, then union with B. So that's the answer to this one. Let's go. A youth club has facilities for members to play pool, darts, and table tennis. So you have 3 sports here: pool, darts, and table tennis. Every member plays at least one of the 3 games. So P, D, and T. They've already given you the letters to use. So who played darts, whatever respectively. You have to express each of the following in set language and illustrate each on diagram, on a Venn diagram. So express each of them in set language and use a Venn diagram to show it. So the first one is, you need to take note of something. Every member plays at least one of the 3 games. That means everybody is involved. That means the 3 circles we touch one another. So you have P, D, and T. This is T, D, this is P. So set of members who only play pool. You have to show it on this diagram. Set of members who only. Take note of the word only. That means no other circle should reach where your hand is in P. So you are in P here. This is the region here. People that play only pool. D should not reach there. T should not reach there. So this is this region here. Now this region here is actually P. P is involved there. T is not involved, so that will be T prime, because T is not reaching here. D is not involved too, that will be D prime. That was in set notation, this particular region here. Okay, that's the answer to that first one. That's the answer to this one. Set of members who play exactly 2 games, neither of which is darts. Play exactly 2 games. So that should not be involved. People that play exactly 2 games. So this part here is 2 games. This is 2 games. This is also 2 games. But I said that should not be involved. So the circle of D should not reach where you want to pick for the 2 games. So this part should not be involved. So the only part that is involved in 2 games is this particular place here. This particular place. So that should not be involved. Since that is not involved, that means D is not involved. That means you have to prime that D. You prime it out. So then you include those P and T, since P and T are meeting here. So that will just be P intersection T intersection. Then you have to prime your D. So that's the answer to that question. Okay. Now for this next question, you have to, for each of the Venn diagram, express the shaded regions in set notation. Okay, you have to express the shaded region in set notation. So this one is one we have done before. I think we have done this one before. The shaded only this part here. So this part here is just B is involved. A is not involved there. So that's B intersection A prime. That's the answer to that one. Then for this one, let's look at the part that has been cut out. This part has been cut out. This part was cut out. But what is this part normally? That part is always A. Since B is not involved here, that will be A. Then you have to prime your B out. But since it has been cut out, you can see that it's white. That means you have to prime this value. So you can leave your answer like this, or allow this prime to enter into the brackets. So that will give you A prime. This one will turn to union, B prime prime. And B prime prime, same thing as B. A prime union B. So you can leave it like this. For each of the Venn diagrams, express the shaded. Okay, I've done that one. Copy the Venn diagram above and shade the region that represents. So we have to copy this diagram and we have to shade the regions that represent A intersection B intersection C prime. Anytime you see C prime, that means C is not involved. Okay, since C is not involved, only A and B are involved. So let's look at this circle of C. Should not be involved at all. So go to where A and B are meeting. So that means you will just shade only this part like this. You will shade only here like this. Don't let it enter into the circle of C. Only this part. This part should not be involved. So that's the answer to that question. Okay, I hope you get it. Then for the next one, you have to copy Venn diagram and represent A prime. That means you are cutting out A. Since you have seen A prime, you are cutting out A prime B union C. A prime B union C. So this is A prime here. This is A. You are cutting this part out. Okay. Since this part is cut out, that means A is not involved. But B union C is just everything from B to C. You cannot shade into this part though, because it will involve A. A should not be involved. So the answer will look like this. You shade everything here. Shade B. You shade C because it's B union C. But you should not enter into A because A is primed. A is being cut out. So you shade everything like this. Shade everything like this. So that's your answer. Sorry about the shading, but just get the basic idea now. You understand? So that's that. So that's A prime. Prime because A is cut off. Intersection B union C. So let's go. So for this next question, you have to express each of the following in appropriate set notation. So X is not an element of set A. That means X is not a member. That's the symbol to use, this symbol here. So X is not an element of set A. So X is not an element. Slash it like that. Then put A like this. That's the answer to number 1. Okay, that's the answer to number 1. For number 2, the number of elements not in set B is 16. Number of elements not in set B. No, that's B prime. Number of elements not in set B is B prime. Okay, so just do number of elements, that's NB prime is 16. So that's the answer. Set C and D have no elements in common. That means they are disjoint. Set C and D have no elements in common. That means they are disjoint. So they have no elements in common. They have C intersection D equals to empty set. Nothing is common between the two of them. Hello students, we have come to the end of the video. So I hope you have gained 1 or 2 things concerning Introduction to Set Theory for MAT 101. Kindly share this video with your friends. Subscribe to this channel if you have not subscribed yet, because I'm going to be posting more videos for MAT 101. Thank you for watching this video. I really appreciate you. Remain blessed. I love you guys. Peace.